goal is to understand combining functions together. So we're doing this after radicals, so if one of the functions is a radical, we know what to do with it. So basically, you're going to add, subtract, multiply, and divide. But instead of adding, subtracting, multiplying, and dividing numbers, okay, these would be functions, and they would be named for you. So remember that f of x and g of x, those are just names, and they would refer to some equation. So somewhere it would say f of x is equal to this. So wherever you had f of x, you would want to use that in its place in order to come up with the new expression. So again, this is straight out of your book, and all it does is show you that there's some different notation. F of x plus g of x is the same thing as writing it like this, f plus g, and then putting the x afterwards, okay? Same for subtraction, multiplication, and division, all right? So those just mean you add, subtract, multiply, or divide, okay? All right, so what that would mean for us, if this is f of x and that's g of x, sorry about my part B, f plus g of x and f minus g of x. What am I doing in parts A and B here? Dylan? Good. So in part A, remember based on the notation we just saw, I'm adding the two functions together. So if written with notation of their name, I would say I am adding f of x plus g of x. But to actually do the addition, I don't want to use f and g. I want to go get what f and g are equal to. So f of x is equal to 5x cubed plus 1. And then g of x is equal to x squared minus 4. Okay. Like you're substituting the algebra expression in for the name of the function. Okay. So remember, things like this, g of x, f of x, are just names. Go find the name and see what it's equal to. That's the thing you need to do the operation with. Okay? And then just like normal, you would combine any like terms if possible. So we have this cubed term, then we have a squared term, then we have two constants that can be added together. This would be what f of x plus g of x is equal to. Okay? A new function where they were combined together. Is that all right with everybody? Okay. So we're still just adding, subtracting, but they're going to use the names in the problems instead of giving you it like this. Okay, so you've done it like this before. The question is, can you get from the notation to this so you know what to do the rest of the way? Okay. All right, and then in the second one, we're subtracting. So the only difference there is that you're going to have f of x minus g of x. And remember, when you're subtracting polynomials, to be careful about distributing the negative to each of the terms. So f of x, again, is 5x cubed plus 1, and g of x is x squared minus 4. But remember that this minus means it's distributed to every term that's present in the group after that. So we have 5x cubed plus 1, and then minus x squared plus 4. So I have a cubed term, a squared term, and again, two constants that can combine together. So this expression is what f of x minus g of x is equal to. Okay? Is this all right? So you should know how to add and subtract polynomials. The new thing for you here might be that notation and just understanding what they're asking you to do when you see that. Okay? All right. So same idea with multiplying and dividing. In part A here, this is f times g of x. So you want to go ahead and you want to multiply them. Okay. So f of x in this case. Okay, and again, I'm going a little bit quickly through this because my opinion is the notation is new, but if someone gave you this multiplication problem before, you should be able to do that. Okay, so the adding, subtracting, multiplying, and dividing aren't new. The way the problem is written for us is new. Okay, so this notation means the same as f of x times g of x. Those are names. Replace the names with the actual expressions that you can do stuff with. Okay. So then here, don't forget to distribute every term to every other term. So this would be like x cubed plus x squared minus 6x. Then if I distribute the negative 2, negative 2x squared minus 2x plus 12. and then combine the like terms just like before. So we have a cubed term. We have our 2 squared terms. We have 2 linear terms and a constant. So that's f of x times g of x. Okay. So what are we doing in the last part? Dividing. Okay. So a little bit of review about how this works. So basically we want to take the f function. It's going to go in our numerator. We want to divide it by the g function, which is in our denominator. So in this case, remember, replace the names of the functions with the expressions that they are equal to. Now, you can either go and do division, or in a setup like this, you can often try factoring. I don't know if you guys remember this from Algebra 1, but you can try factoring the numerator and see if there's a factor that cancels. So does x squared plus x minus 6 factor? Yeah, to like x plus 3 times x minus 2. And then you have this x minus 2 in the denominator. So these are common factors. That saves you the work of doing the long division or the synthetic division if they have common factors and the factors cancel. Okay? So are we okay with that fact that this is notation? The notation uses the names of the functions. But in essence, you're doing all things in this case that you did in Algebra 1. You're adding 2 expressions together, subtracting, multiplying, or dividing them. Is that okay with everybody? Okay. All right. Okay, so this is where the hard part comes in. It gets a little more confusing, so that's why we went faster through the other part. This part is going to require us to think. So the other part was just like, okay, there's some notation there that I got to get used to. Now here, there is a different idea, okay? This is the idea of composition. Again, this is straight out of your book. Okay, it's in your note-taking guide if you have it. Composition means you're actually plugging one function into another function. Okay? So in the past, you could have had a function that was named f, and somebody might have asked you, we actually did this in the last unit, find f of 3. What did it mean to go find f of 3? See? Good. Plug 3 in for x in the function that had the f in its name, right? The thing is, they don't have to give you a number to plug in, and that's where it gets a little bit more complicated. They could ask you to plug in f of x minus 2. What do you think that means to do? Plug in x minus 2 for x, okay? Where you would have normally plugged in a number, now you're plugging in like a whole expression, and that's okay. Which means they can make the notation even slightly more complicated, and they can say plug in f of anything. And in this spot, they can give you anything they want to plug in. So what they do sometimes is instead of actually telling you what to plug in, like plug in x minus 2, they do this. What are they asking me to do in that case? CJ? Louder. Good. Whatever g of x is equal to, they want you to take that and plug it into f. Okay, so it's actually asking you very similar, something like this. They're going to take some expression that they want you to plug into f, but instead of writing the expression out, they just keep using the names of the function. So one of the hardest parts of this section is just going to get used to the fact that those f's and g's are names. Can I interpret what they actually want me to do from how they're writing these names of these functions? Okay? So sometimes they write it like that. You can see that right here. Okay? G of f of x. That means go find the f function, and whatever it is, plug that into g. But sometimes they write it like this. This does not mean multiplication. What's the difference between the notation right here and the notation we saw for multiplication? Damien? Yeah, it's an open circle. So that means composition. So please don't confuse them. They are two completely different types of operations. So one of the most common errors that I see people do is they see g of f of x, and because g is next to f, what do you think they want to do with g and f? Multiply them, right? They just want to lay them next to each other, distribute, do whatever they have to do to multiply them. But f is actually inside of g here, and that means you got to plug something into something else. So make sure you distinguish in your mind When are you multiplying and when are you doing this new thing called composition, okay? Does that make sense to everybody? So really try to separate them, okay? So let's look at how to do this. All right. So up here, we'll do this with some functions, and then in part B, you'll see we'll do it with a set of points in case it's not defined as a function. So the notation says to find two things. Okay. Yes, it looks like fog. A lot of people refer to them as like fog and goth because they use the letters F and G a lot, and that little composition symbol does look like a little O. Okay? So F of G of 3 means the same thing as this if you don't like that notation. It means F is the last thing you're going to plug into. And being plugged into F is this thing, G of, and instead of saying X, like the whole G function, they actually told you a number they want to plug in for G. Okay? Kind of like order of operations, if you had a problem with a bunch of parentheses, where would you start? The most inside tucked in one, right? That's kind of the idea here. Here's where we want to start. We want to change the name to an actual expression. Sometimes it'll have numbers if they give us numbers. Sometimes it will just have different powers and stuff of x if they give us x. Okay? So this says G of 3. So it should actually be a number because we have G of 3, right? Meaning we're actually plugging in 3. So we're not even dealing with F first. It's like first step, figure out what's actually in here, not by its name, but what does it actually look like. So I have to go figure out what is G of 3. Okay. So look up. We're in part A. What does the G function say? G of x equals, so this is like my off to the side. G of x is equal to x cubed. So that means G of 3 would be equal to 3 being cubed, which is 27. That means I can replace the name G of 3 with an actual value of 27. Is that okay with everybody? Okay. So I calculated this essentially, and now I'm saying I don't want its name. I want what it actually is. It is actually 27. Okay. And then just like with order of operations, now it's like you have a new operation to do. What's the next instruction that we have to do at this point? What are we supposed to do now? What does this mean? Austin? Good. Plug 27 into the function called f. So now you have to go find the function called f. Okay. I look up in this problem, f of x is defined as being x squared. So if I want to find f of 27, that means I'm actually taking 27 and squaring it. I don't know what that is on the top. What is it? 729? I can't hear you. Okay, thank you. Okay. All right, so 729. So we found f of g of 3, and it was equal to 729. So the way you would write the final answer is you're going to write what you found. I just found f of g of 3, and it came out to equal 729. Okay. Remember, this is a label. This is a name expressing what I did. This is the actual simplification or the answer that I got. Okay? All right, we aren't finished even with part A yet. So what I'll do is I'll take part A, we'll take up my whole screen, and then I'll do it again for part B, okay? So I have space up here. The reason we haven't finished part A is because the directions said to find f of g of 3, but also to find g of f of 3. Now, sometimes they will work out to be the same things and sometimes they won't. Totally depends on what they decide to call f and g. Okay, so don't think like, oh, they're the same thing. They're really not, because you do the order of operations differently. And you guys have done order of operation problems before. You know if you do things in a different order, you get a different answer, right? So this is a different problem. So the second part of part A says to find g of f of 3. And again, if you don't like that notation, you can write it this way. It's g of, and what's being plugged into there is f of 3. Okay. They'll be written the same size when you see them. I like to write it smaller because I think visually it helps you guys understand better that that's something separate and it's being plugged into the other one. I don't know. Helps me see it better. All right, so the first thing I want to do is go find what in this case? F of 3. Okay, I need to calculate this. So I'm going to go find the f function. Remember, we're still in part A, so it's defined as x squared, which means f of 3 will be equal to 3 squared, which is 9. Okay? So that means I no longer am going to write f of 3. Instead, I already calculated it and simplified it, and it's easier to just call it 9. Okay, that's what f of 3 is equal to. So now what do I need to do to finish the problem? Good. So I need to plug 9 into the g of x function. So I need to go look at the g of x function and understand what it is. So it says x cubed. So g of 9 would be to plug 9 into that function. And 9 cubed is 129. Okay. So g of f of 3 equals 729. So these worked out to be the same. Will they always work out to be the same? No. The reason these worked out so nicely is because we took a number and squared it, and then we took that number and cubed it. In the other problem, we cubed it first and then squared it. We worked with exponents over the last few days. Does it matter if you cube or square in which order? No. But if somebody added a +1 to one of these, would it change the answers? Yeah. Okay, it would definitely change it, and we'll see some places where it will. Any questions about this? Okay, so how to do this with points? Looking at it with points is like reading a chart. You don't get to plug in like we did right here and always take a function and always get an answer. If a function is just a set of points, like see how f is only those 3 points? What are the values I can plug into the f function if it's only defined as those 3 points listed right there? Damien? Good. Well, the x coordinates. Okay? So the only numbers I could find are f of 1, f of 2, and f of 3. Do you guys see where I'm picking out those numbers from? If somebody asked me what is f of 5, is there any point in the f function where 5 is the x coordinate? No. So we're not used to reading a chart of points, which makes it a little more difficult, but it actually narrows down the possibilities quite a bit. So it should make our life a little bit easier once we understand how to read it. So let's look at part B and then find f of g of 3 and g of f of 3. Okay, so for f of g of 3, oh, white. Okay. And again, if you don't like it written that way, you can rewrite it like this. So we want to find f of g of 3. What do we need to go find first? G of 3, okay? So you go to the g function. Now, the function's a little bit different. It doesn't say g of x and you get to plug in whatever you want. So to find g of 3, you want to go to the g function. You want to look for some point that has 3 as an x value, and you want to look for what is the y value that goes with that x value. When you plug in 3, what do you get out? So in the g function, when we plug in 3, what's the output? So you look at the points. There's the point with the x coordinate of 3. And the output that goes with it is 1, which means g of 3 is equal to 1. Okay? So this gets replaced with 1. And now my goal is to go find f of 1. Okay? So who can raise their hand and tell me what f of 1 will be? Good, -7. I look in the f function. When 1 is the input, -7 is the output. So f of 1 is equal to -7. Okay? So f of g of 3 turned out to be -7. Again, name, as complicated as it might look, right? And what it became. All right, then what about g of f of 3? Or we could write it like this if we want. So somebody tell me what to go do first. New people each time because we've gone through the process a couple times. Damien already told us. Just like. Good. Okay. Good. So she says f of 3, and she says it will be 0. So look at the f function. When the x is 3, the y that goes with it is 0. So f of 3 is equal to 0. Okay, what do we do next?
Find where 0 is in the f function.
In the...
So g of 0 would be f of 0, and then we find where 0 is in one of those points.
Okay, good. So we are looking for g of 0, but we don't have to look in the f function. So we're only going to look in the g function for when 0 is the input. Okay, which means 11 because of the point 0, 11. Is that okay with everybody? Okay, so once you've gotten rid of 1, you only need to deal with the second function. So this means that g of f of 3 is equal to 11. Is it all right with numbers? Okay. It gets a little more complicated with there's some variable stuff going on. So are we okay with the number foundation? We get the notation, we go find this first, then we take that and plug it into the second one. Do you understand that you have to plug into 2 different functions to complete this? And that I could make it longer if I wanted. I could have, like, what's h of k of g of x? And then how many functions would you have to plug it into? 4. H and k and g. And okay? Make sense? Okay. All right. Yeah, that didn't edit, right? The answer's 2. It's actually not 2. Actually, let's skip this for now, and we'll come back to it. Let's talk about this. Gosh, sorry about the formatting. I don't know why. I think when I open it on one computer, it then changes when I open it. Give me 1 second. Let me see if this is good. Okay. All right, so I know you say we're actually going to do them together, and then we're going to go back to that example I just talked about and try it a couple different ways so that we understand what's going on. Okay, so this says find g of h of x and h of g of x. Okay, so for part A, I'm going to do 2 things. I'm going to find g of h and h of g. Okay, 2 separate things that it's asking me to do. Okay. All right. No numbers this time. Makes it a little harder, okay, because we're not necessarily used to not having a number to plug in, okay? All right, so g of h of x. So again, we focus in here first. What is h of x? So before it said like h of 3, and we'd go find the h of x function, plug in 3, and do a calculation. If it just says h of x, what is it asking you to put in there? Zeke?
The h function.
Good. The h function just as it is, right? Because it's defined as h of x. So what is h of x equal to? Do you guys see what he's pointing to? So it says h of x is equal to negative 3x plus 1. So what I want to do, though, remember, is I want to take out the name and put in the actual expression or function I want to use. So instead of calling it h of x, I don't want to call it by its name. I want to call it by what h of x is equal to, which is, okay? Now, what is this asking me to do? Soraya? Substitute negative 3x plus 1 for x in which function? The g function, okay? So the g function looks like, let me write it like this. So I'm going to write what the g function looks like. So I'm going to go to this function. I don't want the name anymore, so I'm going to write what it's equal to. So it's equal to negative 2 times x squared. And what I'm going to do, this makes it easier for me. And if you have a hard time knowing what to plug in where, you should do this too, okay? What this allows me to do is this is the g function with nothing filled in for x. And then I'm just going to go copy what they're asking me to fill in any spot where I have that extra set of parentheses waiting for something to be plugged in. The reason I point this out, if I ask you guys to find g of 5, most people don't have a problem. If I ask you to find g of x plus 1, A lot of people will write g of x and then write a little +1 at the end or things like this. But we have to understand we're actually plugging a whole function anywhere there was x in the other one. So anywhere x showed up, which would have been right here, we need to plug in this whole entire quantity. Okay? And then you have to use all the skills you know about multiplying, adding, subtracting, like terms, all that kind of stuff to simplify this. So the first thing you would want to do is you would want to square this. Okay? So you're going to have -2 times whatever that is once it's squared. Who can tell me what -3x plus 1 is when you square it? Elijah. Good. Great job, not just squaring both terms. So this comes back to what we talked about yesterday a little bit, right, when we were solving those equations, that like we tend to get wrapped up in what we're doing and forget that if this is squared, we actually have to write it out and FOIL it, and this is what you would get. Okay? Then I'll distribute the -2. So I'll get -18x squared plus 12x minus 2. That is what g of h of x is equal to. Okay? Sorry, and I should do a better job here. You should write g of h of x equals. Sorry. Okay. The reason you should do that is if I ask you to do both these things on a test, and you just write these answers without labeling which one is which, it doesn't tell me if you knew what you were doing, because a lot of people know, like, oh, I just have to plug stuff into other stuff, but they don't actually read the directions of what to plug into what. You know, they're a little bit different. Is this idea okay with everybody? All right, so what about h of g of x? Okay. Means I'm going to do h of what? What am I plugging into the h function? -2x squared. Okay. And then you don't want the names there. I don't want h here. So I need to go look at the h function. I need to see what it is. The h function says -3 x plus 1. Okay. And if it had another x somewhere else in the problem, I would just keep writing out all the terms, and anywhere x showed up, empty set of parentheses to fill in with whatever they say, no matter how complicated it is, okay? So in my empty set of parentheses, I'm going to fill this in. So here, to complete my simplification, there's no exponents, so the first thing I'm going to do is multiply these two things together. That will give me 6x squared. And then I have this plus 1. Those can't be combined together, so this is it. And this is h of g of x. Is this all right with everybody? Yeah. All right. So for part B, we're going to do the same thing. So we're going to find g of h of x and h of g of x. All right, new people. Let's say you're helping your friend with this problem. What do you tell them to write in the next step to find g of h of x? Michael. Good. So h of x is going to be replaced with x minus 3. Okay. All right, next step. Someone new. What do I do now? Now it says g of x minus 3. Kyle. Good. So the g function just has absolute value bars around x. So I want absolute value bars around, not x, but whatever they're telling me to plug in for x, which is... Is there any simplification of that expression? No. So this means g of h of x is equal to the absolute value of x minus 3. And that's it. Okay. All right. Good job, new people, stepping up to help us. All right. What about h of g of x for the equations given in part B? Somebody tell me what I would write after that. So the problem says h of g of x. Huh? Good. So g of x is replaced with the absolute value of x. So now my problem says find h of the absolute value of x. Somebody tell me how I'm going to do that. Cameron?
Absolute value that is -3.
Good. So in H, it looks like something minus 3, and the something is whatever you're plugging in. And in this case, you're plugging in this, and then those parentheses are unnecessary. So we get the absolute value of x minus 3, and that's what h of g of x was equal to. Okay. My advice to you, don't try to go too fast, okay? Otherwise, you get confused. And then I do want to point out one thing. Okay, let's say you have this. I'll put back up that other screen in just a minute if you guys need it. If this says h of x equals 2x plus 5, okay, and I ask you to find h of x plus 1 versus h of x plus 1. What is the difference between these two things that I'm asking of you? What is this first one asking of you, part A? Do what? Cameron?
It's 2x plus 5 and then
Good. It's saying just take the entire h of x as it is. They didn't change it at all, right? And at the end of it, add 1, right? And so then this would end up being 2x plus 6. Is this okay with everybody? What is the difference then when I ask this in part B? What is h of x plus 1? Quentin? Good. Plug x plus 1 in wherever the x is. So the x is here, x plus 1 goes here, and this doesn't end up being the same thing. This is 2x plus 2 plus 5, which ends up being 2x plus 7. Okay? So you can see that if I changed this plus 1 or made it a little more complicated, this would be drastically different than this instead of just a little bit different. So really pay attention to what they're asking you to do and let your brain process it before you just start like going as fast as you can. Yes? Right, right. That's correct. That would be not possible for you to find. Kristen?
we always have to leave the absolute value values though, right?
Yeah, there's nothing further you can do to simplify this because you don't know what x is. So if the absolute value bars are around something that has a variable in it, you need to leave them there. If they were around a number, I could go and calculate that number because I know how absolute value works for a number. But a variable's unknown, so you don't really know what to do with it. Okay? Any other questions? No? Okay, so let's stamp our stuff.